Here we're going to have a look at 2012, question 9, part B. So this is a submerged rods question. Now, rod is hinged at point P, 2 meters long, weighs W. Now, a few little twists in this question is that we're given the relative density of the rod, 0.756, and we are given the relative density of the liquid. Okay, let's see how we can get on with this. So, first things first, draw ourselves a lovely little diagram. That's point P. There's our rod. Angle theta. There's our little liquid. Now, let's have a little look at the forces, or distances we know. There's a 0.4. Here above the water, that'll be useful. The whole rod is 2 meters long. There we go. And we are asked to find the portion underwater. So I'm going to call the portion underwater, from there to there, x. Now I know we could do 2x because our buoyancy force is going to be halfway along it, but Charles, I know myself, if I call this portion 2x and make my algebra a little bit easier, I will forget that the question is really asking for the value of 2x. So I'm going to pop this in as an x because it's just a little bit less likely to make a small mistake at the end of the question. Okay, so we are told that this liquid here, the SL equals 0.9. All right, and S of the object, let's see if we can squeeze it in over here. It's getting kind of busy. SO equals 0.756. Now, length of the rod. So let's have a look at our forces. Well, we have the weight going down, which we are told is W, and we have the buoyancy force going up. I'll send it right up here through these guys. Okay, so let's see what we can figure out about the buoyancy force first. Well, our equation for buoyancy is weight, specific density of the liquid, over specific density of the object. Okay, important not to forget that because, you know, a lot of times it's water, but in this case it is 0.9. So that means our buoyancy, buoyancy. Now, when we say weight, we mean, of course, the weight of the fraction underwater. So the fraction underwater is x over 2 by the weight. Specific density of the liquid is 0.9. And over here, the specific density of the object is 0.756. Okay, that is ugly and horrible, so we're going to tidy it up. I'm going to sort it out in my calculator. So what we have here is, we'll just deal with the numbers here for the moment. We have 0.5 by 0.9, 9 over 20, divided by 0.756. I'm going to hope this is a nice little fraction, and it is indeed, 25 over 42. I'm going to leave it as a fraction then. So that is 25 over 42 Wx over nothing. Okay, so there we are, over 1. 25 42 Wx. All right, so now we know our buoyancy. Next, we're going to look at moments about P, since that's our little hinge. Well, the moment bringing it clockwise is b by this distance by opposite sine theta, and bringing it counterclockwise is w by that distance sine theta. So we have, put it in as buoyancy for the moment, just so we can see where we're going. The distance here is 2 minus that little bit there, which is x over 2 by sine theta, and that equals the weight by this distance here, which is just half of 2, which is 1, by 1 by sine theta. Okay, and we can let go of our sine thetas there. Now let's sub in for buoyancy. So we get 25 over 42 Wx factor of 2 minus x over 2. There's going to be a little bit of algebra in our future here, equals w. And we can knock out the w's on both sides. That's not quite so ugly and horrible. All right, let's see what we can figure out here. So I get 50 over 42, 50x over 42, that's these two, minus 25x squared over 84. All right, and that equals 1. So we can see we have a fairly clear common denominator on the bottom here. So I'm going to try and tidy this all up a little bit. So we'll multiply everything by 84. So that ends up being, if I convert that into 84s, that is, well, we'll keep our x here for the moment. So actually, tell you what, I'm going to lose my pluses and minuses first. So what I'm going to do is just switch them all here. If I switch them all in place, I can now end up with a plus x squared. It's just a kind of nice, easy way to just write them in over it. So, multiplying by 84, that is 25x squared. Okay, that is 100 over 84, so that is minus 100x. All right, bringing this over here, this is plus 1, so that is plus 84 equals 0. Now we're getting a bit closer on it. Now we'll do it 25s. I didn't want to do it all in one go because I could have tripped up a little bit here. Only takes a second. So that is 25 dividing by 25. X squared minus 4x plus 84 over 25. Right, fun times. Well, you can have a quick little think of this one. I suspect you're probably not going to figure this one out, in your head, so it is the minus b formula. So let's come up here with a little bit of space. So that is, of course, minus b plus or minus square root of b squared minus 4ac over 2a. You should absolutely know this off by heart, but look, we're just going to stick it up there anyway. Now, best way to screw this one up, and this is a particular favorite of mine because I can sense the end of the question coming up close, is to just substitute in wrongly. All right, so I would always take a quick little moment to write this out. A is 1, B is minus 4. Okay, the most common thing people screw up on this one is they don't bring the minuses. They think B is 4 or something like that. And C is 84 over 25. Now that I know this, this is just nice and straightforward. So here we go. We have 4 plus or minus, actually, technically speaking, that is x equal square root of 16 minus 4 by 1 by 84 over 25. Okay, you can convert that into a decimal if you like, but it doesn't really matter. We're going to put it all in the calculator anyway. And that is all over 2 times 1. Okay, the reason I'm putting the 1 in the brackets, even though it seems really obvious, is just a reminder to myself not to forget a. Someday it won't be 1. Okay, so let's see what we have here. 16 minus 4 by 84 over 25. Okay. So I end up with x equals 4 plus or minus. Now, just looking at that, okay, you may or may not spot this. See if, there we go. 64 over 25. What do we notice about 64 over 25? Well, there are 2 squares. Okay, now you could always just do a square root of it. Square root 1 3/4, 8 over 5. 8 over 5. All right, so just so we see it there, equals 4 plus or minus 8 over 5 all over 2. Let's lose the 2. X equals 2 plus or minus 4 over 5. X equals 2.8 or 1.2. All right. Which one is it? Which one is it? Because we are asked for a particular answer. Of course, if we go back to our question here, we see we can rule out one of them straight away. If we look at the total distance is 2 meters, so x is less than 2 meters. X is less than 2. Therefore, x equals 1.2 meters. All right, and that's part 1. Now, for part 2, we actually have a small little bit of space. I'm going to see, can we squeeze part 2 in just here? Because it is not nearly as hard as it looks. The value of theta. Well, let's see what we have. And my little hint to get me thinking is, I know this distance here is 0.4. So let's draw that little diagram. Okay. There's a little thing. We know that is 0.4. This is the water, or the liquid. So this distance from there to there is 2 minus x, which of course is 2 minus 1.2, which is 0.8. That's theta. So we're saying the cos of theta equals 0.4 over 0.8, and that equals 1 over 2. So cos of theta, sorry, 1 over 2. Theta equals, and if you don't know this off the top of your head, that's okay, cos inverse 0.5, 60 degrees. Just drops out nice and neatly once you see which triangle to use. And of course, the 0.4 is a little hint. If you think about it, we haven't even used the 0.4 yet. It's sitting out on its own, dying to be part of things somehow. And there we have it.